Hey everybody, I wanted to spend a little bit of time showing you how to use the simulator that I'm asking you to use for the gas laws demo. One of the things that ends up happening is that gas laws are very integrated with each other. The properties are. So when we have pressure and volume and temperature and number of moles, all of those things are related to each other and they all affect each other in a gas. We can also simulate this using this this site, and this is what I'm going to want you to do. So you can use the link, or you can go to this website right here, and then you can click on gas properties. Now, here's what we're going to do. I'm going to ask you to talk about pressure and how it affects temperature and volume of a gas, but I'm going to show you how to do this with temperature. I'm going to show you what we're doing here. Okay, so here's what I'm going to do. Okay, I want to figure out how temperature affects the pressure. So if I want to figure out what the temperature and the pressure relationship is, I'm going to hold volume, the thing I don't care about, constant. I'm going to hold that constant. And so what I can do is I can heat this up, and when you heat it up, notice a little fire comes up, but also notice that the temperature gauge here goes up, and we can see the temperature in Kelvin of the gases in the container. Notice what's happening to the pressure gauge. As I heat this up, pressure increases. And then I can do the same thing here. I can cool it, and that's good. Okay. So as temperature is changing, I can see what's happening to the pressure. As temperature goes up, the pressure increases. As temperature goes down, the pressure decreases. Okay. Now, the next thing I want to do is see how temperature affects volume. And so what I'm going to do is I'm going to click this. So I'm going to see how temperature affects volume. So I'm going to hold pressure constant, and this little thing means that the volume is the thing that can change up and down. Okay, so as I heat things up, notice what happens to the volume. The volume gets bigger. This thing gets much bigger. As I cool things down, notice this thing gets much smaller. And so that's the relationship that you would have. As you heat things up, the volume gets bigger. As you cool things down, the volume gets smaller. Now that makes a lot of sense. Let me just spend a second talking about the chemistry a little bit. If we're holding pressure constant, pressure is the number of impacts that the molecule has. The molecules have on the side of the container. So as we look around, the molecules are impacting the side of the container, and that's creating a pressure. If we heat up things, what happens is we heat up a gas, the molecules speed up and therefore are hitting the side of the container more. So in order to compensate for the increased number of impacts on the side of the container has to get bigger to keep the pressure the same. So that's kind of the relationship that heat and pressure have. So what I'm going to ask you to do is do the same thing, except I want you to change the volume. If we look here, you can see that the volume can be changed pretty straightforwardly using this thing. So what I want you to do is I want you to change the volume and see how volume affects the pressure, and then see how volume affects the temperature. Once you get done with that, then you can just turn in the assignment on the Google form and just have a great day. I hope everybody's staying happy and healthy, and we'll see you later.